Hello everyone, I hope you all are doing well. So in this session, we will be discussing about the mathematical intuition behind KNN algorithm. Although I have shown you in the previous video that how it works, what's the algorithmic intuition behind that. Today I'll take a numeric example first of all to showcase you the internal working so that you will be able to have a better understanding of the same. Also, I will discuss that how optimally we will be able to find out the value of k. If you remember in the last video, I have talked about something called as elbow method. So today we will see in this video that how this elbow method works. Then maybe in the upcoming video, it would be great if we will try to create a separate video for implementation per se. Whatever things we will discuss in this video and the last video that we have discussed, I will try to showcase you the entire concept in the upcoming video in terms of implementation I am saying. So without wasting any time, let's get started. So now let's consider that we have 8 points in our data set. As of now, I am taking a very hypothetical example just to make you guys understand that how this k-means clustering algorithm works. So just observe that we do have these 8 points available with us, where the value is 2 comma 10, 2 comma 5, 8 comma 4, 5 comma 8, 7 comma 5, 6 comma 4, 1 comma 2, 4 comma 9. And let's assume that I want to create 3 number of clusters here. Again, this is my hypothetical value. As of now, I'm not talking about any optimized number here. Just consider that this 3 indicates the number of clusters. The number of clusters. Okay. Now, what will happen? As I told you, the very first step is to randomly initialize any of the points as their centroids. So let's assume that I have taken this as centroid C1, I have taken this as centroid C2, and I have taken this as centroid C3. So randomly, I have taken 3 centroids. Now, what algorithm I told you in the last video, that first of all, what will happen is it will try to calculate the individual distance of all the points with respect to the C1. So what will happen is there is an evaluation which will happen between the distance C1 comma P1, C1 comma P2, C1 comma P3, C1 comma P4 until C1 comma P8, because we do have 8 points. Same thing. So this is the distance computation which will happen, right? Distance computation which will happen. Similarly, the same thing will happen with respect to C2 points. C2 with respect to P1, C2 with respect to P2, until the number of data points that we have, C2 with respect to P8, right? And the same exactly similar kind of a thing will happen for the cluster number C3 as well. So C3 with respect to P1, C3 with respect to P2, and so on until the last value of the distance C3 with respect to P8, right? So in this case, what you will observe is that what we're trying to do is we're trying to achieve a distance value of each and every cluster points, maybe C1, C2, and C3, with respect to all the points that we have. Now, what is our target thing which we want to achieve? We will try to see the minimum distance. For example, because P1 is only the C1 value, it will be 0, right? There will be some value here. Let's say I'm assuming 5. There will be some value here. Let's say I'm assuming 10. It's a assumption. And here you can consider any of the distance. Maybe I'm picking up Euclidean distance. Similarly, let's say P2 ke saath mein we will be able to have a distance value as, let's say, you will observe it will be maybe 10, it will be 7, it will be, let's say, 5. So what will happen is with respect to every particular clusters, we have a points value, we have a distance value with respect to every point. Now what we will do, or what internally algorithm will do, it will try to take the minimum distance. So we know that point P1 belongs to C1 now because it is having a minimum distance, the value is 0 as comparable to C2 and C3. So we will finally say that the point P1, which is 2 comma 10, belongs to the cluster C1. Similarly, you will try to do the same task and you will observe that, let's say, the point P3, point P4, P5, P6, P8 belongs to centroid C2 because it is having a minimum value as comparable to cluster C1 and C3 with respect to the points P3, P4, P5, P6 and P8. Same thing you will do, and you will observe that with respect to the points P2 and P7, the minimum distance value is C3 as comparable to C1 and C2. Once you are able to achieve this task, what you will do? You will try to find out the new centroid. Now, because it contains only single point, so centroid will remain same, 2 comma 10. With respect to C2, what will happen? Now you know that P3 has its own x value, P4 has its own x value, P5 has its own x value, P6 has its own x value, and P8 has its own x value. 5 points are there, right? 8 plus 5. So new centroid value with respect to C2, the x value will become the average of, you will say 8 plus 5 plus 7 plus 6 plus 4 divided by 5. Similarly, for C2, the y value will become the y-axis will become the y-axis of this 4 plus 8 plus 5 plus 4 plus 9. So what we will be able to achieve, which is 4 plus 8 plus 5 plus 4 plus 9 divided by 5. So what will happen is, with respect to centroid C2, we will be able to get a new, I would say, value, which is the average of x and y. So in this way, we will be able to get a new centroid C2 dash, you can say, which is the average of all the points belonging to C2 value. Similarly, for C3, now I hope you will be able to understand P2 and P7 we are saying, right? So the x value with respect to C3 will become 2 plus 1 divided by 2, because there are only 2 points we have, and y value will become 5 plus 2 divided by 2, right? In this way, we will be able to achieve a new centroid value for C3 as well. So what will happen is, now we will be having a new centroid of C1, C2 and C3. Same thing, we will repeat it again. What is that thing? We will again try to do the recomputation of the distance, maybe Euclidean, maybe Manhattan, to get the minimum distance value with respect to the centroid C1, C2 and C3. So in this way, we'll be able to get an idea that how we will be able to form a new clusters at every point of time. Now, at what point of time we will stop this algorithm? When you will observe. So stopping criteria will be where you are feeling that in the next iteration, when you're repeating this task, you're feeling in the next iteration, the new values of C1, C2, C3 is almost same, is almost similar, which we had in the previous iteration itself. It means now my algorithm stops changing, which we had in the previous iteration itself. It simply indicates that somehow my model is not rotating now much, right? Our centroids are somehow stable now. And that is where we will be able to say that, okay, now we will be able to form a stable cluster, right? So everything is here dependent on the distance wise, right? The lower the distance means they form a cluster. They have a capability to form a cluster. Now, in interviews, there is a very widely asked question that there is another concept of k-means plus plus also, which came into picture once k-means algorithm came, right? Researchers have designed a default configuration for now whenever you will call this k-means algorithm in the practical implementation per se. I'll show you the documentation also. You will observe by default k-means plus plus is mentioned. Let me show you this part as well, what I'm trying to convey here. For example, this is the documentation which you can again refer sklearn k-means documentation. You will see initialization is k-means plus plus. So although we will do the implementation in the upcoming session, but let me show you that what is the difference between what we are discussing as of now and this k-means plus plus. It's an advancement of k-means, which signifies where researchers have just make sure one thing, that we will try to define the randomly assigned clusters in such a way that they will be distance apart. Researchers did some research, and what they have observed is they try to define a advancement of that k-means algorithm, where they say that this centroid's initialization which you are doing will be at far distances. Now, why is that so, and why is it important? Why is this important? Because initially, when this k-means clustering algorithm came into picture, let's say you are saying I will be having too many data points available with me, right? You are saying that I will be having too many data points available with me with respect to maybe here and you can say here as well, let's say. And now this algorithm of normal k-means clustering algorithm says ki we will randomly initialize any of the data points as centroids. Now the question is, let's say my model assumes these two as centroids. So now what will happen is we automatically will be having only one cluster, because all the data points are near to these two centroids are near to this one circle only. We may get rid of all these data points, right? There is a biasness. There is a biasness in this case because of the closeness of these clusters. This can be anything, right? These two as well, right? So what we have to make sure that whatever be the clusters we are initializing in the very first stage, they should be distance apart. And if they should be distance apart, in that case it will make a great clusters. That is where k-means plus plus came into picture. That is the simple advancement which this k-means plus plus algorithm does, right? So if someone in an interview will ask you, that is the simple response which you have to give. Also, I would recommend, please go through the research paper which researchers have published after the advancement, which is basically helping you out to get the clear understanding that how mathematically these things different. Okay? Now, let's try to understand the last important question, which is again very widely asked in interviews, and even in practical implementation, you will observe we will use it very widely. That is how we can find the optimal value of k, which is the number of clusters. And for this, you have to understand the concept of WCSS. The full form is within cluster summation of within cluster summation of squares. So, what is the meaning of this? It simply indicates that what you will do is let's say you will be having three clusters available with you. Okay? And this is the centroid, let's say you will be having all these other data points which is available. Similarly, here also you will be having this as a centroid. Let's say this is C1, this is C2, and this is C3. And again, you will be having several data points available on this cluster. You will be having several data points available within this cluster. Now, what is the meaning of WCSS? WCSS says that we will try to find out the distance of, so summation of I is equals to 1 to the number of clusters we have. Summation of I is equals to 1 to the number of data points we have within one single cluster. We are trying to find out the difference between the cluster C of I, right? C of I minus the points value which we have, P of I, right? Whole square. Sum of summation of squares. What is the simple meaning of this? What we are trying to signify from this equation, what I'm trying to convey here is, we will try to find out the distance of this centroid with this. Similarly, we are trying to find out the distance between centroid C2 to these data points that we have. Similarly, we are trying to find out the distance between the centroid C3 with this data points that we have. We'll do the summation of square with respect to every centroid distance value, and then we will add it. Right? For example, here you will be having points P1, P2, P3, P4, P5. Here you will be having X1, X2, X3, X4, X5. Here you will be having, let's say, Z1, Z2, Z3, Z4, Z5. Let's assume I am just showcasing you just to understand you the concept basically. So what you are doing is you are trying to find out the difference between C1 minus the points P1 whole square plus C1 minus P2 whole square until so on C1 minus P5 whole square. So this is the one thing which you will be able to get. Similarly, you will do the same task for the C2 as well. C2 minus X1 whole square, C2 minus X2 whole square. You will do the same task until C2 minus X5 whole square. Same thing you will do for C3 as well. So C3 minus Z1 whole square plus C3 minus Z2 whole square until the value of C3 minus, let's say, Z5 whole square, data points that you have. Now, whatever results you will be able to get, you will try to add all these results. So that's what it's called as within cluster. So within cluster that we have summation of squares. So what we are doing is we're doing the squares and then we're doing the addition of all these cluster values that we have. Now, why I'm trying to indicate this term? Because there exists a chart, or we call it as elbow method, where we try to create one important display of chart where the x-axis indicates the value of number of clusters which is K, and y-axis indicates the value of WCSS, which just now I have explained you what is the meaning of that within cluster summation of square. Now, what we usually try to see, let's say I'm saying maybe you are dealing with the number of clusters. Let's say you will be having 0 cluster, or let's say 1 cluster, right? In that case, what is the value of WCSS? What do you think? What I'm saying is, when you will be having a value of K as 1, what is the meaning of that? Simple meaning is that you will be having a single cluster. In that case, what is the value of WCSS? Can I say in that case, I will be having a single centroid? And to find out the distance of all data points with respect to that single centroid will be maximum. Can I say it will be maximum value? But when I goes below, and let's say I reach to a point where the number of clusters is equal to the number of data points that we have. What I'm saying is, in this case, number of clusters will be equal to the number of data points that we have. In that case, the value of WCSS will be equals to, can I say 0? Why is that so? Because in that case, you will be having whatever data points you have, there are the clusters also. So distance from that cluster itself is 0. For example, in the above case, the example which I have showcased you, the cluster is also same point, P1 is also same point, distance is 0. So what we are indicating is, as we move below, as we increase the value of the number of clusters, what is happening is the value of WCSS will keeps on decreasing. So what does this elbow chart indicates? This is the implementation which we will do in the next session, but I just want to showcase you the elbow chart in this particular video. For example, you can see here, right? What we have done is, let me just open this Epic pen and to try to showcase you the concept which I want to signify here. Can you see? This is the value of K, which indicates the number of clusters here. And you will be able to see this is the value of distortion score, which I would say is WCSS only, which I'm just trying to explain to you. So what is happening is, as the value of K keeps on increasing, as the value of K keeps on increasing until the value of number of data points, value of WCSS will keep on decreasing. Now, what does this elbow method say is that there exists a elbow. For example, in this case, this is the value where the value of K is 3. After which there would not be any drastic change in the value of WCSS. Can you see? After this K value 3, there is not a drastic change in the value of WCSS. Initially, there is a very drastic change. There is a very drastic change. But after this K value as 3, you will be able to observe the drastic change is not there in terms of the value of WCSS. And that is the point which gives me the optimal value of WCSS. This is the point which is actually I'm looking for. And this is what elbow method says. So elbow method says, let me just erase this. Now I hope the picture is pretty much clear to everyone, because I have shown you with a very perfect example. So let me again go back to my writing pad and let me show you what I want to showcase now. So let me just close this toolbar. So what I'm saying is, as you move down, because of this illustration which I have shown you, it will start from maximum and it will go downward. But what you will observe that after some point of time, there exists a point. Like you will observe that it is decreasing. Let me showcase you again. It is decreasing. It is again decreasing. But then there is not a very sharp decrease which you will observe. Maybe like this. So that is something which we are calling it as a elbow, where let's say the value of K in this case is 3. So we will define that, okay, this is the optimal number of clusters which is required as per my data set. Now this value of K will vary depending upon what is the data you are using, what kind of data you are using, what kind of features you are using. But this is the overall idea behind this elbow method, and this is how we will be able to achieve that optimal value of K. Very important concept. Definitely it can be asked from you in an interview as well, that how will you optimize this value of K. So in this video you have observed two important questions as per interviews: difference between k-means versus k-means plus plus, and how will you able to achieve the optimal value of K. I believe both of them I have tried to showcase you with a very practical example, with a very mathematical intuition behind that, so that you will be able to understand it very much amazing manner. If you still have any issue, please do let me know. In the upcoming video, just now I have shown you the file, right? That same thing, we will do the understanding of that same file, how this k-means clustering algorithm implementation is being done. And everything I'll try to showcase you in a very concise manner. At any point of time, if you're facing any difficulty, please do try to reach out to me, maybe via mail, maybe via LinkedIn profile. You just have to search Priya Bhatia. You will be able to see on me via LinkedIn as well. And with this, let's end today's video. I will see you all in the upcoming video where we will discuss another amazing concept, where we will talk about, first of all, implementation. And further, in the upcoming videos, you will see another amazing clustering algorithms we are discussing. So I hope that you have enjoyed till so far. Please make sure you will give the feedback as well. And with this, I'll see you all very soon in the upcoming videos. So now I hope that you will be able to get a clear conceptual idea that how this k-means clustering algorithm works, what is its mathematical intuition, how elbow method works, how we will be able to find out the optimal number of clusters, what is the idea and or the concept behind the WCSS. I hope everything is pretty much clear to everyone. So now the only part which is pending is the implementation, which we will cover up in the upcoming video. So please stay tuned. I'll see you all in the upcoming video, where now we will discuss the implementation of this k-means clustering algorithm. Bye bye everyone, and see